Today on Dead Dodge Garage, I spend several minutes looking frantically all around the shop for my power probe. Before I remember that I have a toolbox. Chrysler fuel gauges. Why are they like they are? Why do they never work? Blech. Oh yeah, I'm sick. The short, easy answer is, I don't know. The long, accurate, and slightly more detailed answer is, several reasons, actually, but probably the most important among them is this: the Chrysler electromechanical gauge voltage limiter. Now, for this lesson, I have to uninstall my temporary permanent assemblage of test pliers from the boat trailer. Here I have the regulator rigged up to a battery, so you can see how it kind of works. Power in on the middle pin, ground on the one that goes to the case, obviously. And the green is the output. I've got the cable here and this terrible rusty clamp. And over here I've got the world's worst multimeter, which I have to hold with my foot to keep it working. If you watch the screen, you can see what this thing does. The voltage fluctuates some. It'll go up to about 6 and back down. And it just kind of hovers around there and keeps the voltage in the range that won't burn up the gauge. The gauge is designed to run on, well, 6 volts, I guess. 5 to 6 is fine. This is a Stone Age electromechanical device. There's a bimetallic strip in here which opens and closes and keeps the voltage around where it needs to be. Common failure modes for these: either they break internally and you get 0 volts, or they short out and you get 12 volts and all the smoke comes out of your fuel gauge. This is a random one from the spare charger cluster. These are found in basically all muscle era Chryslers. There are different versions. In some earlier cars, say from 66 and back, they're built into the fuel gauge, which is lots of fun. You know, when that dies, inevitably. But this is pretty common to find. I'm not going to get up behind the cluster of the Demon right now, but there's definitely one of these up there. I showed you this first because it's culprit number 1 when your fuel gauge is dead. But there are a couple other components you need to know about: the gauge and the fuel sending unit. I'm using the Demon as an example because the fuel gauge is actually dead. Dale seemed to think that it's probably the sending unit in the tank, and he may well be right, but I wanted to go through the steps and verify that. Before we actually dive in on the car and look at stuff, I came up with this handy diagram to show you the different components here. It's a relatively simple circuit, but there's some voodoo in it. When you turn your key to run, one of the fuses energized in the fuse box sends output to the voltage limiter on the back of the gauges. You know, that little thingy. And you can see here, there's power input, power output, and of course, a ground, which is important. Let's just call this 5 volt output for simplicity. It goes from the limiter to the fuel gauge. The fuel gauge has 2 posts. Positive in, 5 volts, regulated, and ground, which goes through a variable resistor, the fuel sending unit. That resistance varies from 73 ohms empty to 10 ohms full, which is incidentally the same as Ford. So if you can't find a sending unit that fits your application, but you can find one for like a Bronco or a Ranger, you can use those parts to fix your Mopar. Ground finally does return through the body of this sending unit and through a ground strap, as this thing is mounted in a rubber ring. It may be able to ground through your fuel tank, but the engineers deemed that unreliable and added this strap. If that's missing, well, that could be your problem too. Important side note: if you're driving down the road and all of a sudden your gauge pegs out when it shouldn't, you could pull over and shut your car off and find the gauge fuse and remove it before your fuel gauge is totally dead. This guy's going to be your problem. Fix that thingy, put the fuse back in, and all will be well. I'm not going to try and tell you which fuse it is. This is going to vary by vehicle. Just find a diagram for your car and you'll figure it out. These cars are 50 years old at this point, and it's very common to have this issue. If your gauge doesn't work at all, it's likely the limiter is dead. Unfortunately, you're going to have to go through some steps to figure out if it's just the limiter Or if it's stuck in the closed position, put full 12 volts on this wire and cook that thing years ago. It can be a little tricky, but step one is verifying a limiter. As with most electrical things around here, I will be completing these tests with my power probe, which, yeah, it's still slightly broken, but it does work. If you don't have one of these, which would not at all surprise me, a voltage meter or digital voltmeter or multimeter will do just fine. You can use the test light to see if you've got power, and you could test the low voltage circuits by seeing how dim the light is. I'm gonna say that's probably not reliable. I'd go with the meter, unless you're really old school. If you do have a power probe, here's a fun and easy test. Take it to every fuse, which is really hard to do through the screen. And make sure you've got power on both sides. I do, except on this one, but this one is for gauge lighting, so that's fine. The gauge lights aren't on. Alternatively, find a diagram for your car, figure out which fuse is for the gauges, and check for power on both sides with the key on. Now, not all regulators are created equal, and what I showed you on the other one may not even be normal. I don't even usually bother with this step. I usually jump right to upgrading them. More on that in a bit. But in the Demon, this is what I seem to have. It fluctuates from 10 or 11 or so to 0. That makes sense. Averages out to about the right voltage. So I'm going to say the regulator is fine. And since my temperature gauge works, well, I already knew that. But there you go. You know, I was going to say something earlier, but I don't know, I didn't. It's earlier. I've only had one coffee. The reading coming out of this didn't really look right. I don't know what that's about. What it's supposed to do is switch on, off, give the gauge full 12, 0, full 12, 0, and it averages out to about 5 volts. This one was putting out 6, and then 2, and then 6 again. So I don't exactly know what to make of that, but it is what it is. This one's probably bad, but who knows? Anyway, now we're under the car, and there you can see the one wire going to the sending unit. Well, you can kind of see it. Whatever. Anyway, tucked here between the axle and the fuel tank. Now, there are 3 tests we can do here. The first is verifying the integrity of the circuit from the gauge to the tank. As you can see here, I have the same fluctuating off-on voltage signal. So we're definitely getting voltage from the gauge. The next test we can do is ohm out the sending unit. Since I don't have my multimeter, I went ahead and just hooked the power probe on there, and it shows ground. Now, it doesn't give us a resistance. There certainly is some, but I don't know how much. Either way, though, that tells us there is a path through this thing back to ground through this strap, which is in place. The other test is to put the power probe in here and ground it out. Not for long now. This could do bad stuff, but for long enough to check the gauge and see if it moves. Because I don't have an assistant and I don't want to leave it grounded for long, I'm going to use the magic of video. Pay attention to that fuel gauge right there. Well, I grounded it out underneath the car. Here we go. Well, what do you see? Is it doing the stuff or not? And back up. Oh, it definitely did the stuff. Oh, hey, while we're under here, note the 4 lines that go from the fuel tank up into that breather pipe in the trunk. This is 71 only. And admire what a solid trunk floor looks like. Never seen one before. Ah, there you go. I solved my problem. It is, in fact, the sending unit. Dale was right. The one thing about that is it's clearly not original. I think it was new when the tank was replaced, but it's bad anyway. Even weirder, you know, there is a path to ground through it, so it's not broken internally. I have a guess about what's wrong, and my guess is the float's cracked, and it's probably full of fuel. And at some point when the tank's less full, I'll probably drop it, pop that thing out of there, and verify that. A couple more notes here. This is everything I just did. Check for 12 volts going into the limiter, which I actually did over at the fuse box, but it's fine. You'll notice in that shot up behind the dash, we couldn't actually see the limiter, so this was about all I could do. I checked the input going from here, and then I checked the output at the back of a couple gauges, and it was correct. You need to make sure there's power going into your limiter and 5 volts coming out, or a flashing on-off, 12 volts, no volts, 12 volts, no volts, etc. You can check that same signal here at the wire going into the sending unit. It should look the same. 5 volts, 6 volts flickering. It shouldn't be solid 12 anyway, that's important. You then check the resistance with this wire disconnected of your sending unit. It shouldn't be an open circuit. There should be a path to ground through there, and it should be somewhere in this range. But if you've gotten to here and everything else looks good, it probably isn't. You also need to verify that there's ground at the body of the sending unit. That's where it grounds through. This is its path here to get back to the car. But you should have ground here if all is well. Going through all those checks in that order should show you where in the circuit your problem is. If you don't have this, but you have it here, your gauge is bad. There you go. It does happen. Now, as I mentioned, I actually don't have a whole bunch of experience testing these things because, well, they're usually bad, and I often jump straight to installing a solid-state regulator. You used to be able to buy these at Radio Shack, but, well, you don't see them around anymore, do ya? This is a solid-state voltage regulator, or limiter, that takes 12 volts nominal in, so 12 volts-ish, and puts out 5 volts. It's not exactly the same as the output of the original electromechanical unit, but it's really close, and more importantly, it's rock solid. It may change your reading somewhat, but your gauge should work. 12 volts gets put in here, and 5 volts comes out here. I screw these to the back of the clusters, and I run an extra ground wire here to a screw, separate, or that one. And that's all there is to it. Well, other than making absolutely sure these don't touch the body of the cluster and become a fire. Yeah, it's real easy to do, they're cheap, and it works very well. Now, another cool thing if you're putting a car together, once you kind of understand how these circuits work, well, it's pretty easy to test them on the bench. And all you need is this mess. I hope this helps clear up some of the magic and mysticism around this small piece of the Chrysler electrical system. Again, it's a pretty simple circuit, but they fail all the time. I've been playing with these cars for, how long? 15 years. And, well, it's pretty much a rule that any old Chrysler you get that's been sitting around is not going to have a working fuel gauge. So I've had more than a few times going through these, and I hope my knowledge helps. What are the chances this one works? I'm thinking low. But even if it doesn't, at least we can fill this big gaping hole. More gauges to test. Fantastic. Oh, hey, one more note. Your temperature gauge is run by the same regulator that runs the fuel gauge. So if both of them are dead, this is probably where you should look first. And if you're lucky enough to have a real oil pressure gauge, it's run by it too. If you have any further questions, feel free to ask them in the comments, and I'll do my best to answer. Thanks for watching. Oh, and if you haven't subscribed, please do. Help me in my quest for global domination, and I promise to keep the useful information coming.